Hi everyone, my name is Ava and today I'll be giving you a brief tutorial on how to use my new method for semi-automated segmentation of trabecular and cortical bone using a VISO. So overall, we wanted to develop this recipe to find a more subjective way of identifying the cortical and trabecular bone boundary and also to do these segmentations more efficiently. So initially, this was developed for segmenting the trabecular bone in the epiphyses of mice, but it can be applied to a range of different bone types. So the first step is to download the recipe from GitHub. So the URL is given there. And there's also a README file, which has a lot more details about how the recipe works. So once you've downloaded the recipe, you want to move it to the VISO recipe folder. So on Windows, the path name looks something like this. It'll probably be different on a Mac. I think you can find it in the VISO user's guide. So then here's a quick overview of the steps before I do a little demonstration. So in general, we want to start with some filtering if it's necessary for your scan. Then you place seeds and run a watershed algorithm and also maybe do some manual cleaning. And those three steps are all to isolate the intertrabecular or marrow space. And then we run the recipe, which shrink wraps the marrow space to then give you your trabecular bone. So I'm going to move to the VISO now. So here I have my scan of a tibia of a mouse. And then I first right click and then get this filter sandbox. So it really depends on your scan. We had a bit of noise and we really want a nice smooth boundary between background and the bone. So we use the non-local means filter here. I suggest really doing this on a case-by-case basis for whatever scan you have. So playing around with the filters. Obviously, you don't want to over smooth any smaller details either. So then once you've filtered, you go to the segmentation module. And you'll want to make sure that your image that you're working with is the filtered version if you do end up doing some filtering. And then we create a new label field. So I called mine, I have the specimen name, the age, and then I put seeds in the name. So it doesn't matter what you name it, but I suggest putting seeds so you know what step this is doing. And then you want to do one layer for the inside, so that includes the marrow space of your bone of interest as well as the bone of interest itself, and then anything else outside, which can also include bone. So here I've done these two. To add new materials, you just do the add button. To add selections to your material, you can do the selection with these different tools and then click the plus button. So I've done all of this ahead of time so I can show you what this looks like. So here you can see I've sampled I scroll through the slices and I don't do every slice. I pick several seeds at pretty big distances from each other. The reason there's a lot of background seeds is because it's just really easy to select, but a VISO actually doesn't need this much information. You know, I didn't need to select all of this background. And that brings me to an important point, which is I think it's really useful to do the seed placement as an iterative process. So do very few seeds, then you run the watershed, see how the two materials separate out, and then just go into the areas that need refinement instead of spending a lot of time doing really detailed seeds that you might not even need. Let me show you in a different view. So here you can see I also selected, even though this is the background, I selected these bones because I don't care about these bones. I don't want to analyze them. So they go in the same seed layer, same seed color as the background. And the way these seeds work, so here you can see in this turquoise color, I've selected my intertrabecular space and the bone around it. You can see also that I don't go super precisely up to the boundary. And this is because, but I do it a bit more precisely here where there's the growth plate area here. And the reason for this is that the seeds and then the watershed algorithm works in growing the seeds until they reach kind of a boundary. So a big difference in the grayscale values. And then it'll see at that boundary, like across the boundary, is there any seeds that are already have grown up to that boundary and are occupying that space. So here, since I have some of the bone selected, it grows all the way up to the background. But then I've told Aviso, oh, connect all the background with this red seed. And so then in the end, we would have the entire background space filled up to the borderline of this bone with red. So again, it works based on gradient differences. And then in some areas, so say you're separating these bones here, you need to be more precise and might need some cleanup later because there it doesn't know, Aviso doesn't know which part is the epiphyseal bone and which is the other bone. So that's essentially how it works. You can see I didn't place that many seeds scrolling through. Then you do the watershed algorithm. This is probably the most time-consuming part. It doesn't take super long to run, but for the purposes of this tutorial, I've already done it to save a bit of time. Essentially, you want to create a new gradient image the first time you do it. So your input is the filtered, you create a new gradient image. Then once you've done that, if you're doing this iteratively, it saves the gradient image. So it'll have gradient at the beginning of the name. So then you can just reuse that. And then you want to have markers selected materials, make sure your materials up here are selected under marker. And then you want the output catchment basins to be side by side. And then you apply and create a new label field. And essentially what this does is it then separates the two regions. So this is one step ahead since I didn't rerun the seeds, but basically what you would get is after the watershed, you would have red on the entire outside. And then it would, this whole, what's yellow and dark blue now would all be turquoise because that's where we placed the seeds. And then all I did to then, so then we have our epiphysis or our bone of interest with the bone as well as the marrow space inside. And then I just used thresholding to then separate those two. So I'm really interested now in getting this trabecular space separated out. And then what I do is once I have that, you can see it's pretty nice. I select it and add it to a new label field. But before I do that, I want to quickly make a note. So there's some areas, for example, here, where sometimes with your watershed algorithm, the inside will kind of bleed into the outer space because it doesn't know exactly where to put this boundary. And you can clean it manually so that the intertrabecular space doesn't kind of go all the way through the sinus. Or you can choose to leave it unclean. We did some sensitivity studies, and even for the small specimens like the mice where the sinus epiphyses, where the sinuses are actually pretty big relative to the general region of interest, it didn't make a huge difference in terms of volume measurements in the end. But I suggest you do some sensitivity analyses on your own data set to see and to consider the sort of questions you're asking to see whether such cleaning is necessary. Same with things like if we cleaned out all these growth bridges. So some of them ended up quite nice, but some of them we cleaned manually. So for example, again, I didn't save this version, but with the watershed, sometimes initially it'll include some of the growth bridges and then you can go back and add some more seeds. So for example, the way we do this iteratively is if there was a region, say here, we wanted to really get a lot more detailed. So say we really wanted to get rid of this area, we would select it like this, still on the watershed output, because there we can really see what the result is. But then you can transfer the selections between layers. So you just select it in one, go to the other label field, which was your seeds, and then you can say, okay, I want to add this to my seeds outside. So to really tell it, go all the way up to here. So that's the way that you would iteratively refine your seeds so that you then have this separation. So then once you have the intertrabecular space, you select it, you make a new label field called intertrabecular space, and then inside you just add that. So I've already done that. Clear this selection here. This is also another step where you could clean the sinuses a bit if you wanted to. It doesn't really matter if you do it this step or when they're all in the same label field. And very, very small sinuses, the algorithm already cleans, like these areas over here. So now that you have that, you want to go to your recipes. And then you want to load your recipe from your Aviso folder. So find it wherever the path name is, select the one you want. I want this one. Open it. Source should be the intertrabecular space, and then we run it. And I'm going to run it in real time so you can see how quick this is. So it's almost done. So it's pretty quick overall. And then in the segmentation, you can see that we have our result. Let me change the color, edit color, red. All right, and there we have our trabeculae. And then in the project, it'll show up also in the project view. And then I renamed it trabeculae, and then you can calculate all sorts of things, again, by right-clicking. So degree of anisotropy, you can do a global analysis, which gives you a lot of things like volume information, barycenter, etc. You can also use arithmetic modules. So you can basically tell it, okay, I want my epiphyseal bone. So that's all the bone in the epiphysis minus the trabeculae. So I have A and B, A minus B, and that'll give you my cortical bone. So that's how you can then create another object just for your cortical bone. All right, and let me go back to the presentation. So a few last points. We also made an intersection over union macro on GitHub, which is a good way for sensitivity analyses. So instead of just calculating maybe volume of trabecular bone between different users or with or without cleaning or manual versus the automatic method, it actually compares the images themselves. So it's a better way of seeing if the segmentation, how similar segmentations are. There's also a step-by-step guide that's linked in the GitHub repository with the mouse epiphysis as a case study. And feel free to email me with any questions. Thank you very much.